So hi everybody, I'm Kayla. I'm a solutions architect at AWS specializing in data architecture, engineering, and AI now. That means I basically act as a technical guide for people running on AWS. I'm going to expand on some of the concepts that Jennifer presented where we talk about responsible AI specifically for generative applications. I work for AWS. This is not really an AWS specific presentation. So we're going to focus more on the overall concepts about how you use this technology. So in general, Jennifer already reviewed what we consider responsible AI and its concepts of fairness, explainability, robustness, transparency, and that goes for generative AI or classic AI. Today, or in my presentation, we'll talk about generative AI specifically. So as Jennifer said, generative AI is a type of AI that's actually generating new content. So more the classic, supervised learning type of applications was more, here's my previous tabular data, makes predictions on some sort of a label, right? Like what house price do you think this will sell for? Is this fraud, not fraud, things like that. Generative AI is going to be actually creating new content, text or images, so like summarization of an existing email, summarizing meeting notes, doing Q&A by searching documentation and giving you an answer back. Also image generation. I'm focusing more on the text today because that's one we tend to see the most often used use cases. So specific caution signals when you're using generative AI. The first one, I think our presenter talked about it. Privacy, where's your data going? If you're using just an open generative model, they often will learn from your data. So you can definitely, put some proprietary data in your question or have it summarize some proprietary notes. Someone else can ask a very specific question and get your data right back out on the other side. So you have to think about where is this data going? How's the model provider using my data? Toxicity, obviously, will the model say something it shouldn't? And we will talk about some ways to mitigate that. Bias, so that's going to be, does this model give outputs that's either biased, or another way we think about it is it giving different results based on the inputs that it's getting or the end user? So like if I ask questions and like, maybe English is not my native language, and then I get really poor results as a result back. Or maybe it's trained on specific types of language that would not perform as well on other types of groups. So you really have to profile the outputs that are coming out of these models. Again, explainability. Explainability is a big concept we think of with classic AI too. Like especially if you do things like health outcomes, are you going to be accepted for some insurance? Credit scores are a big one. Are things like someone's protected class becoming big predictors or features that are being used to make decisions? And Jennifer touched on this, but sometimes even if it's not explicitly, someone's race in a model, most people know not to do that now. But there are often features that might track with those protected classes. Data ownership. Again, we talked about this a little bit around privacy, but the other aspect we think about is all these models were trained on large open source data sets on things on the internet, things that people may have produced without the thought that it could then be used to like generate new IP from something they wrote. So data ownership, where did this source start from, is also a consideration specifically with generative AI. So we'll talk about how to mitigate this. And the first thing I want to level set is that generative AI is powered by machine learning, deep learning, reinforcement learning, classic reinforcement techniques, or classic machine learning techniques, but it's also very different in some ways. The reason that's different is because of the vast amount of data these models are trained on and the number of parameters they're trained on. So these are things that just wasn't possible to do before advent of like cloud computing and then limited compute capacity, GPU chips, those types of things. So now we have these very, very powerful, what we call foundation models that have learned the basics of, how to speak English, how to write a sentence, all these things that, traditional ML models, we used to have one machine learning model for each of our tasks. So, if I had a fraud model, I trained it from the ground up to predict fraud, not fraud. I couldn't then use that same model to predict housing prices, different algorithms, different hyperparameters, different training data. When you're talking about generative AI, it takes all this unlabeled data, big corpuses of text, and it learns so much that it can be adapted to all these various applications with very little tweaks. So in customizing these large language model or LLM applications, there's kind of this, curve of how much customization and how much work are you doing. And sometimes us as data scientists, we think we need to like train everything ourselves from the ground up. When you're talking about foundation models, because they're so big, they took so many parameters. Most of the foundation model providers who built these spent like millions to billions of dollars to train them and have teams of like 100 PhDs who are all focused on this training aspect. So generally, unless you have high levels of funding and you have plans to monetize your model, you're not going to be building a foundation model from scratch. And there are lots of extra considerations. Jennifer went into some of them actually. If you were training a model from scratch, that's not the focus of my talk. I'm going to be focusing on what most of us as users, as enterprises are going to be doing, and that's going to be selecting a pre-trained foundation model. Sometimes fine-tuning it, which we call fine-tuning. It's essentially like I made that reference. These models to learn to speak English, to form words and sentences, how people talk. Think of it from like age 0 to like college. And then from like maybe grad school, there's a lot of medical people here, I imagine people have secondary education, where then you had specific courses where you had to learn, like read a bunch of white papers, case studies, things that are very dense medical texts. But after maybe a year of tutelage, you actually got pretty good at understanding that stuff. That's kind of like fine tuning in that if you fine tune a model, it's like a small training model of a foundation model, but you might only have to give it like 20 samples of a scientific white paper. And it's like, okay, I get how we write scientific white papers. There's a pattern here. That's essentially fine tuning. From there, we talk about giving it extra context that it was not trained on. We call that retrieval augmented generation. And it's essentially, there's a lot of public examples of, models hallucinating. Maybe it was trained on data up till like 2020. And then I ask it, who's the president? It would say Trump. And it's like, that's not the president anymore, but it was the world as it was when it was trained, right? I just talked about how expensive and a pain it is to train these models. So every time a new fact comes into the world or that I wanted to know about, I don't want to just retrain it from scratch. I just want it to know that that fact exists. So what we call that is retrieval augmented generation, or RAG for short. That's essentially just giving these models an external corpus of data. And we'll talk about that a little bit more. From there, prompt engineering techniques from zero shots is essentially, I just ask it to give me an answer without giving it any examples, which some of the models do decently enough with, but it works better. I give it a few examples in my prompt, just like if you were talking to a human, right? Like if I just say, write me a summary of this essay, how long do I want it? What tone do I want it to have? That type of stuff, if you just show someone a few examples of what their output would be, you get a little bit more, what you would expect and what you would desire as your outputs. Think of it the same as talking to a human in some ways. You have to have reasonable expectations and giving it reasonable amount of data to work with if you want some sort of repeatable result. So we'll talk about these customizations and then how they apply to this overarching theme of responsible AI. Yep, so just to recap, I'm going to be talking like retrieval augmented generation up. I'll just leave training out of it. You're a user of these foundation models. So when we're talking about this, as you might have guessed, when you're talking about generative AI specifically, we're starting to have this pattern. We're all standing on the shoulders of things we don't necessarily fully control. And there's responsibilities at every layer of this platform. The first one is going to be the platform that's hosting these foundation models. So that's going to be something, do not share data with external parties. We talked about that privacy issue. Do not leak data between tenants. So tenants would be, individual users and companies for a foundation model. Provide standard regulatory safeguards. So things like encryption in transit and at rest when you're talking to these foundation models. So I'm sure healthcare, you guys have HIPAA, you have all sorts of types of regulations. Sometimes you have PCI requirements. So the platform has to give you like the tools to use that. So with AWS, we have basically two services. We have something called Bedrock that just hosts a bunch of foundation models. So it's essentially like a platform where you can access all of these pre-trained foundation models. We also have a machine learning service called SageMaker. That's essentially you just buy one of these foundation models, but you host the endpoint. And then when you're talking about platform, if you're hosting your own endpoint, sometimes you have to think about how am I doing this myself. If you're working through a third-party provider where there's like AWS, Bedrock, OpenAI, things like that, you have to understand what are their service level agreements to you and how are they handling these things. So that's just the platform. Didn't train the model, not necessarily always even hosting the model, just giving you access to the model. Up there is going to be the model builder. The next step up is the model builder. So that's going to be those foundation model providers that we were talking about who already pre-trained all this data into a trained model that you are going to be using for your generative AI applications. So that's going to be your OpenAIs, your Anthropics, your AI21 labs, your Coheres of the world, Hugging Face. Like, what data do they use? How did they train it? Do you trust them? How are they working or doing on these benchmarks? And I just have a few examples of, foundation model providers. They all kind of have this is how we are taking, responsible AI seriously. And there's no real standard of how they talk about how they do this. And most foundation model providers, if you're not working with an open source model like Hugging Face, they won't publish how they train their data end to end or the exact data sets they use because that's their secret sauce, right? So you won't know fully how they did it. They all have, different things on their websites or their model cards of, Cohere publishes their safety benchmarks of how their models performed with these various safety tests. Anthropic has a very large constitution. They call themselves the ethical AI company, so they're very, very into it. Doesn't mean their other models aren't ethical, just means they have a lot of documentation. Again, not exactly how they did it necessarily, but in broad strokes. So you can always refer to those and, models you're comfortable with. That might be something that goes into which models you select as a model consumer. All right, so then model tuner. So that's where we are now. After we've selected our model and we have some business application we want to point it to, it's going to be, are we giving it unbiased and responsible data? So I said fine-tuning a model to make it like a little better at specific use cases. You're in that case, you're supplying my 20 white paper PDFs, like I'm responsible for at that point, the data that I'm providing to train these models fine-tune to be clear, these models on is now my responsibility. And then some of the things that Jennifer was talking about do come into play about how are you monitoring your training processes when you're fine tuning. When you are doing something like RAG, where you're just providing knowledge and context, again, you're providing the examples, you're providing the data. At that point, you're taking on some part of the responsibility of what's going to come out of these things. So application integrators, so people that are deploying these models, app dev people, DevOps people, front end people, how are you exposing these to your users? Jennifer showed a lot of examples of people trying to break like ChatGPT or make it, say something super toxic so that they could write a news story about it. Those things do happen, and it is a problem that the model providers are also taking responsibility for, how and releasing like this iteration does this a little bit better. But as you is like from an enterprise perspective, you probably shouldn't just be exposing these foundation model endpoints with no checks and balances between your user, right? You own the front end, you'll capture their prompts, you'll intercept their prompts. How are you putting in guardrails along the way? And then obviously here's end user, like do your end users know not to do this? Are you giving them, are you putting guardrails so they can't do it? Things like if I do what, that reporter did of like trying to make ChatGPT say something toxic, like I can't really go like sue ChatGPT for that or OpenAI for that, right? Like I was just like doing an exercise of making it break something. So there's responsibilities all the way down the chain when you're talking about toxic output from these models. All right. I also linked this. This is from AI 21 Labs. They are another foundation model provider. There's a lot of them. There's going to be more. As we go into the future, you're just going to see more and more of these things pop up. But I liked these because they have some pretty common sense guidelines. This is for their, open playground that anyone on the internet can access, but I still like it for things about responsible usage, because working with companies, companies are always asking me like, how do we make sure we're not sued? What happens if, who's responsible, right? If the output is toxic. And with few exceptions, often like at that point, you've generated the output as a company. So you need to think about how you're using it. And if you're using it for an application that could put you in that position. So, common sense, obviously illegal activities. And then down the list, also things like, you can tell these foundation models like, here's a list of classifications that I want you to pick from based on this input. Like if you're going to put like a list of protected classes to classify it, not good, right? And you're the one who's telling it to do that. If you're going to then use those features to make decisions on who gets like, insurance applications or a certain rate or something like that, but really not good. Of course, people will have grounds to sue you, right? And I will say in the healthcare space, like as I work with enterprises, my guidance is generally start with your least risky use cases first when you're first experimenting with this technology. The healthcare space, I think you guys will need to think about it even more because you are already in such an important space. Like misdiagnosing a patient and then something happens to them that causes them death or other damages or sickness. Human doctors get sued for that every day for medical malpractice. So like, how are you applying this? And then if you're going to apply it in those risky situations, the more and more important guardrails along the way become. It also has some other very smart, just kind of common sense things. Like if you're doing a chatbot, maybe just say, you're talking to an AI, make the human know they're talking to a robot, not a human. Maybe have a button where they can submit feedback if they get a toxic response. Like those things aren't necessarily technically challenging, it's being thoughtful about how you're applying it along the way. And Jennifer mentioned, importance of diverse teams. I would also say like, involve people and business stakeholders across your business who have knowledges of this area, like lawyers, definitely too. Because things that I say might be like, this seems obvious, but if it's just you as, you know, a team of 5 machine learning engineers, you don't necessarily think through end-to-end the application. So it's very important for everyone to be involved as a business of how are we using this technology. Because if you put 0 guardrails, you let it make decisions that will have damages from people. You can't just say like, you know, I'll keep picking on ChatGPT. ChatGPT made us do it, right? Because you had so many stops along the way where you are influencing the output that's coming out and how you're using it. All right, so that's the shared responsibility model. As a human, let's like think through end to end how we're using these things. So from technical perspective, I'll talk about like the easy mitigation methods. So this is going to be like things you can do with just prompt engineering. Before we even get to like a lot of the metrics and models that can evaluate the output of other models that Jennifer was talking about. So when you're using this in an enterprise, so I just have one line of Bedrock code, I apologize, not a Bedrock presentation. But the important thing to know is no matter what foundation model provider, what platform you're using, in an enterprise context, you're going to be typically having some like compute application layer, some front end that's calling one of these foundation models, right? You're not just giving it like a foundation model's like playground window that anyone can access. You're kind of in the middle, so to speak. So when you're actually deploying these models as an organization, you're almost always going to be deploying it through an API call. So that's where I just say, you know, we have a line of code that says invoke model, and I pick the model that I'm going to invoke. And then my content's going to be basically my prompt, the text. So tell the model what you want to do, pass in like any context. Here's the email you can put to summarize, etc. So that's how you're using it at the enterprise. There's always going to be like a compute layer where you're just making an API call. So everything that goes around that, you know, prompt engineering. A lot of people talk about how like prompt engineers are now going to be like a job description. It's probably true, because if you get into prompt engineering, it can get very, very complex pretty quickly. And also each of these foundation models have their own like formats, like, you know, shortcuts, things you can tell it, formats that it likes. But at a high level, elements of a prompt are going to be instructions. So tell it what to do. You know, summarize this statement, write an outline, give me an answer to this question. That's my direction I'm giving it. Here's additional content, context. So this is what I want you to summarize. And then your input data is going to be usually that big context, like I'm telling, you know, the email. If you're doing RAG, the actual like documents from your company, things like that. And then usually an output indicator. So like I said, usually you want to show it like some example or this is where you're going to put my output. So like I said, most of the foundation model providers have their own kind of formula, how you do these, like Claude, like the human assistant, like those words exactly. So we can't go all the way into prompt engineering, but we have some good resources. I imagine everyone doesn't want to stay here for 4 hours with me. So just saying prompt engineering. Oh, and I almost forgot the most important thing I was going to say about prompt engineering. Easiest way to like make sure, and it doesn't always work, you still need monitoring. Easiest way to ensure you have like output that doesn't hallucinate. At the end of your prompt, just always say, you do not know the answer, do not make up an answer. Use only this input provided. And like I said, if we go back a little bit, you always have a pass-through for when you say invoke model or whatever API you're calling, where you're putting in the context. Even if your users are inputting their context, you intercept it, you can always tack that on like in your text before it actually makes it to the model. So easy fix for a lot of things around like wrapping some of the prompts. You can also do things like if this is a Q&A and a user is trying to put in like 1,000 words, it's maybe like they're trying to break something, maybe you have like some limit of characters, and then always wrap your context with, if you do not use the answer, or if you do not know the answer, say you don't know, do not make up an answer, things like that. So again, you can also, from a toxic perspective, say, do not add any toxic output, do not use any like biased or, violent language. Again, like doesn't always work. You still need a monitor, but why not? Right? It's super easy. All right. So then the second piece of defense we have is going to be what we called adding additional context or knowledge base. So what I called RAD is going to be, let's give these models some knowledge sources, whether it's like our company documentation, our Q&A, SQL databases with the data they should query, and let's give that the information it's supposed to pull from rather than like whatever it learned in its training phase that we don't really know what it was trained on, right? Like it learned English, things like that, but we can be a little enforcing about like, here's where you pull from. So when we talk about RAG, retrieval augmented generation, for those that don't remember me saying that earlier, the biggest thing, first thing to understand is that even though these models are kind of talking in words and giving us sentences back, they're still machines at the end of the day. They're just dumb machines. They think in numbers. They don't actually know words. The way we get them to understand words or sentences is by first converting them to vectors. It says essentially what a vector is going to be like a list of points that will put it somewhere like on a 3D space. And so if you see here, you can see like when you map cat out, it's closer to feline, which is closer to kitten, and you see dog, it's closer to puppy. And there's lots of algorithms on the back end that do this mapping for you. They're called embedding models. So it's yet another LLM. They're LLMs specific to embeddings, which is what we call converting words to vectors or numbers. So one thing that this really enables that's cool by itself, but is also used in foundation model applications is called semantic search. So previously, most searching that you did on websites for like documentation and things like that, it was just doing keyword search. So if I ask some documentation, like what are the headwinds facing the construction industry, be like, I don't see headwinds anywhere in this documentation or these news articles, right? But with semantic search, because again, it understands which words are closer to one another, it can start to pull out those relationships. So it might be able to say like, oh, this site closed, interest rates went up, all of those things, and it actually understands that those things are closer together. So that by itself is very powerful. And then when we're talking about like a LLM type context, when you're pointing like a generative AI model to someone, and maybe I ask it a question and it goes into like my own corpus of data. It's all it's doing is like converting my question into vectors and then pulling information and documents that map to that vectors. And those are what I can enforce it to use when it's giving me an answer. And when you do the semantic search, you actually can get results retrieved. So you can even go a step further when exposing it to your users and reference the sources from its answer. And again, you combine this with things like use this source for this information. So this is what I was starting to talk to, but essentially here we have our foundation models. We have the question, and in between, we're having the foundation model convert the question to vectors, pull relevant information out of our document store as vectors, and that goes into the answer. So that's a big way to both enforce non-toxic output. Most companies' Q&A section on their website or whatever you have is not toxic, or it shouldn't be. But also you're enforcing like, where did this source come from? You didn't make it up, right? So against both of those things. So this is a kind of end-to-end example of like a chatbot context. So when we're creating like a vector store, and so you may have heard of vector databases. It can be a lot of things. Postgres has vector columns. open search and Elasticsearch can be vector stores. Pinecone is a popular open source one. Basically, we have our document, so that might be the PDFs, words, text. We want to have some model convert it to vectors, and then we store it as vectors in a database. And then our actual foundation model is actually on the back end doing this query before it gives back an answer. So that's essentially what we call the RAG pattern, and any enterprise or company that wants to do this at scale with any sort of like reliability is going to be incorporating like external knowledge bases through this pattern. Because otherwise, what value are you really adding, right? It's just a pass through to just like ChatGPT. The last pattern I'll touch on, how are we doing on time? 7:11? All right, I have a few more minutes. I'll try and stop by 7:20.
7:20? That sounds good.
Is that all right?
Yeah.
So people have time for questions. The other pattern I will just touch on, we won't have time to talk about it. It's a pattern called react. It's reason and acting woven together. And essentially this is how you can make these applications super powerful, because I can say, here foundation model, here's a list of tools that I want you to use. And those tools can be like any generic function. So I can say, when somebody asks for their user history, go to this database and issue this SQL query. If I need to do math, here's the math function. It's very flexible so that you can like chain them together. So this is like another pattern where even if your problem is too complex for it to be solved with like just a simple vector search to one store. In that case, maybe we're expanding it. So that one store is one of various number of tools that it can query. And again, you're giving it direction over in what situations, and what steps do you need to go out and make a query. So I'll again pass this to you. This is like advanced prompt engineering, essentially. Like I said, prompt engineering is a lot deeper than maybe people think. But we'll give you some resources. So like the big three of like easy, I'm not even talking about like metrics or monitoring. I'm just talking about like prompt engineering, chaining things through RAG, giving it data stores and making sure like I'm prompting it in a way to use those things. That will go a long way and is something you should be doing regardless of how robust your downstream monitoring is. All right, so I'll briefly go through evaluating LLMs. Jennifer luckily covered most of this, so I'll be pretty quick. But like she said, it's harder to judge the output of LLMs because it's not a number. Like when I, classic trying to predict fraud or not fraud, I had like accuracy and precision. And it's a very simple calculation of how many fraudulent predictions did I predict were fraudulent, things like that. In this aspect, we're actually giving some output of like an essay. So it is like creating an essay. What is bias? What is toxic? What is correct? That's not a simple, straightforward math calculation. And here I will just switch over to, there are a few models or a few frameworks that are often used. So like Helm is one. And then another is Luther AI, and essentially these are frameworks for testing these various models. But the thing to know about these, and I'll come back to these, but the thing that I want to emphasize is I'm not super deep in this space myself. I'm more of the application make things go together type of person. But the metrics themselves, there are a lot of people doing deep studies on how they build these metrics. Because again, what is bias? What is toxicity? So there's whole research papers of this is the model we train to detect bias, and every 2 weeks a new metric comes out and it will say in like scientific speak, this is why the other metric was trash. Like it's its own area of like ongoing research. So like the metric you use to evaluate these is likely to change over time. It's more important that you have some framework to use a metric. So we'll go through, we talked about problematic output, and then benchmarking data. So we'll talk about how we do this kind of at scale from like an architecture perspective. So I'm gonna kind of go through quickly here. In general, when we're talking about evaluation, we're talking about accuracy, quality, factual, is it non-toxic, is it responsible? one we haven't really talked about and haven't emphasized in this talk is efficient. That's kind of its own beast, so to speak, but often you'll see the best models are also the biggest models. They were the most expensive to train, they had the most data, they have the most parameters, so it's sort of like pointing a Cadillac at everything. And in this case, when you're picking a model, you'll think about like, is it good for this use case? Does it work, with my requirements? But also what's the cost? Because sometimes for what you need, you don't like the ChatGPTs, the quads of the world, the Jurassic models. They're very big. They're very expensive to host because they're large in size. You need a really giant instance, even for inference when you move beyond training. So you will get those costs passed on to you as a consumer. Each query is going to be more expensive when you're querying on the large language models. If you want to host them, the hourly rate to host those large language models are more expensive. So efficiency is something that like you may want to think of through cost, right? If you're weaving this throughout your application or throughout your enterprise, cost is a big deal. And the nice thing about cost is cost generally goes with compute resources, which goes with like how much energy was used to train this thing, how environmentally responsible is it. So when you're trying to lower your cost, you're also like lowering your environmental impact, which many companies are trying to like think about, right? Now stakeholders and shareholders are starting to ask companies like, now we're thinking about your compute. It's not lost on us that all these data centers cost a lot of energy resources and environmental effects. And so how environmentally responsible is your application, which like I said, most businesses are at least very motivated to lower their cost. And so efficiency is there as well. All right, so let's switch on. We kind of talked through all of these already, so I'm going to go through them just for the sake of time. The biggest takeaway is you want to think about this from your initial model selection, but you also need to think about benchmarking it on your own data. So popular options I mentioned, Helm and Luther AI, you can run them yourselves. There's model cards for everything. There's pre-trained toxicity models, which Jennifer talked about. And then there are ways of detecting bias in your vectors, which I will get into the next slide. All right, and Jennifer also talked about this on supervised benchmarks. It's the idea of some of these super models that are really large, really good at detecting this stuff. You can have maybe the smaller, maybe not quite as smart models doing a lot of the work and having one of these big brain models evaluate the quality of the output. That's also a pattern. All right, so we'll show some example architectures. We're just gonna skip through here. I always talk too long. So we'll talk about like putting it all together. So in this case, you'll see a few SageMaker, AWS SageMaker ones. You can just sub that for any foundation model when you're talking about generic. So top layer, you'll have some application layers. So that's mainly your actual code that's putting in prompts into these foundation models. And you may want to, the biggest thing is, like I said, kind of straightforward, but you should always be saving your prompts in the outputs somewhere. In this case, we're showing like an S3 bucket, but the prompts that are coming in and output that's coming out should always be saved in something non-ephemeral, because then we can also point some of these other models to evaluate with some of the frameworks that Jennifer was showing. So you can also, and you can also do things like putting that in dashboards and stuff, but that's how you can monitor ongoing after your deployment, that things are, sticking to what you expected them as far as like toxicity and bias. Yep. And the last one is the embedding analysis. I'll probably just skip this because it's probably too long to explain and I'm out of time, but I hope that was helpful for everybody. We also, I'll just plug, we have a free AWS machine learning course. It's at 8 hours available to everybody. We also have a pretty good article from Amazon Science that just talks about a lot of what I talked about, specific problems with fairness, responsibility in the generative AI era. So we'll give you those resources. Thank you.